This is day 11 of Unit 9, or the second day of Part B of Unit 9. So we started with this warm-up, so take a moment, pause your video, try the warm-up, and then play to check your answers. So first of all, n plus 3 factorial simplifies to n plus 3 times n plus 1 less, which is 2, times n plus 1 less, which is 1. And then I'm seeing that factorial is in the denominator. So I have n times n plus 1 factorial. So the n plus 1 factorials are going to factor out, and I'm left with my answer, which is the quantity n plus 3 times the quantity n plus 2, and that's over n. Of course, I need a restriction though. So first of all, from the original denominator, we can say that n is greater than or equal to -1. Again, that comes from the fact that I can have 0 factorial, so -1 would make this 0 factorial, which equals 1. Secondly, this time there's an n left as well, and we know from our experience earlier this year that we can't have the denominator equaling 0, so I need to include a second restriction, and that would be n cannot equal 0. And that's my answer. Okay, number 2, radio station picking its call sign must use 4 letters and 1 number. How many call signs can they choose from? Well, first of all, the 4 letters in the decision chart, and then the 1 number. When they're referring to letters, we know the 26 letters in the alphabet. It doesn't say anything about not being able to repeat, which means we can. And when we're talking about numbers, unless they specify otherwise, they're referring to 0 through 9, which would be 10 numbers. So then I'm going to multiply that and get 4,569,760. Okay. All right, so today's lesson, we started with this example, and really this you can you should be already ready to do. So take a moment, try it. So if there's 4 digits, there's my blanks, and then we're talking about numbers, and it says they may not repeat. So 10, 9, 8, 7 is what we do, and 10 times 9 times 8 times 7 is equal to 5,040. Okay, now we talked about that in class. We talked about that. This is one way to do the problem using the decision chart, but also this problem and many of the others we've already done are actually what are called permutations. So you want to add that to your notes. Permutation. A permutation, 2 things have to happen. First of all, the order of whatever it is we're doing matters. So we are not only choosing something, but we're then arranging it in a specific order. So the order matters. And secondly, whatever it is that we're choosing and arranging in a specific order cannot repeat. No repeats. And if those 2 things happen, the order matters and no repeats, that's what's called a permutation. So if you think back to the problems we did yesterday, some were permutations. The order mattered and we couldn't repeat, but others we said things were allowed to repeat or the order didn't matter. So in which case we would not be able to, first of all, that wouldn't be called a permutation, and we would not be able to use the formula that I'm about to show you. But if those 2 things are true, then we can use the permutation formula, which is NPR. The N and the R are subscripts. They're written lower and smaller. And the formula says I take N factorial and I divide that by N minus R factorial. So in this particular problem, well, actually in all problems, N represents the number you're choosing from, and the R represents the number you're choosing and arranging. So in this particular problem, we're choosing from 10, and we're choosing and putting in a specific order 4, because it's a 4-digit password. So using the formula, that's 10 factorial divided by, in parentheses, 10 minus 4 factorial, which is 10 factorial over 6 factorial. Well, if I keep simplifying that like we did yesterday, the 6 factorials are going to factor out, and we're going to be left with 10 times 9 times 8 times 7, which is exactly how we did the problem when we did the decision chart. Okay, so just wanted to point out that this formula eventually does simplify to our decision chart. Okay, and that's your permutation formula. Also want to point out that this step right here, 10 factorial divided by 6 factorial, that is us taking 10, 9, 8, 7, which is what we had yesterday when we did the problem with the decision chart. It's taking that and putting it in factorial form. And remember, we did that yesterday as well. We started with 10 times 9 times 8 times 7, and then we went backwards and put it in factorial form. That's where that factorial form is coming from. It's actually coming from the permutation formula. Okay, so let's continue here. Let's try this one. So 25 sculptures, judges are picking first through sixth place. How many ways can the judges select the winner? So when you start a problem, you want to decide, is this a permutation or not? If so, use the formula, and if not, you'll use a decision chart. So does the order matter? Yes. And can we repeat? No. Once you get first place, you can't also get second. So this is a permutation. We're picking from 25, and we're picking and arranging 6. So that's going to be 25 factorial over the quantity 25 minus 6 factorial, which is 25 factorial over 19 factorial, which the 19 factorials will cross off, and I'll be left with 25 times 24 times 23 times 22 times 21 times 20. And that simplifies to, let's see here, 127,512,000. Okay, sorry about that. So 512,000. Okay, so continuing. So here are 52 contestants. We're picking Miss Teen and her 3 runners up. Again, order matters, and no repeats. So that is a permutation. 52P4 is going to be 52 factorial over 52 minus 4, which is 48 factorial. And the 48 factorial is going to cancel out, and I'm going to be left with 52 times 51 times 50 times 49, and that simplifies to 6,497,400. Okay, now B, we have a combination lock that has a 3-number combination, and the numbers are 0 to 35. How many combinations can she make if none of the numbers can be repeated? Well, no repeats, and the order does matter. So permutation. So we're picking from 36 because we're including 0. So 36P3 is going to be 36 factorial over 33 factorial, which is 36 minus 3. And the 33 factorial is going to factor out, and we're going to be left with 36 times 35 times 34, which is 42,840. Okay. Now, just one kind of interesting thing here. We'll talk more about what are called combinations in the next couple of days. Combinations, actually, you're choosing but not arranging in a specific order. So with combinations, the order doesn't matter. But the weird thing is, and I don't know why, but whoever named combination locks actually didn't know their math very well, because they should be called permutation locks. So permutation lock would be better because the order matters. When you put your numbers for a combination in for a locker, it has to be in a specific order. Otherwise, it won't open. So they really should be called permutation locks, not combination, but I don't know why they're for some reason called combination locks, even though mathematically speaking, they are permutations because the order matters. Anyway, just food for thought. Okay, this one. We have cheerleaders. They have cards with Wildcats, the letters for Wildcats printed on. And I noted in class, the only reason we didn't do Eagles is because of the repeating E's. So we'll talk more later about how we would deal with those repeating E's in Eagles. But for now, Wildcats, there are 8 letters. So you can do this problem one of 2 different ways. You could either realize 8 times 7 times 6 times 5, which is going to be just all the way down to 1, which is going to be 8 factorial. Or you could use the permutation formula. There's 8, and we're choosing and arranging 8. So 8p8, which is going to be 8 factorial divided by 8 minus 8, which is 0 factorial. And I told you yesterday that 0 factorial equals 1. So 8 factorial over 1 is just the same thing as 8 factorial, which is what we said when we thought of it that way. So either way, we're getting 8 factorial. And let's see, what does 8 factorial equal? I don't think I have that answer. Well, whatever 8 factorial equals, I'm not going to take the time to grab a calculator, but 8 factorial, whatever that equals, that's your answer for number 4. Okay. Lastly, here we're going to decide whether these are permutations or not. Now, notice I didn't say permutations or combinations because sometimes a scenario might not be a permutation or a combination. And again, we haven't talked a whole lot about combinations yet. We'll talk more about those in the next couple of classes. But for now, just is it a permutation? Does the order matter? And no repeats are allowed, or is it not a permutation? So first one, 4-digit numbers we're making using 2 through 8, and the numbers may not repeat. So no repeats and the order matters. That is a permutation. Letter B, same scenario, but the numbers may repeat. If they may repeat, it's not a permutation. C, all the possible license plates can be made using the letters A, B, and C. Well, if I really want to, I can make BBB my license plate. So that is not. Okay, Scrabble tiles, A, B, C, they're on the tiles. I can't repeat them because there's only one letter on each tile, and the order matters because I'm putting them in arrangements, so that is a permutation. From a group of 8 candidates, 3 will be selected to be on a committee. That's just a committee. They're equals on the committee. The order that I pick them doesn't matter, so it's not a permutation. On the other hand, in this last one, I'm picking them in a specific order. I'm picking president, I'm picking vice president, and I'm picking secretary. So the order does matter. And we can't repeat because once someone is president, they're not also going to be vice president. So that is a permutation. The order matters and no repeats are allowed. Okay, your assignment is page 3 all, and on page 24, just problems 1 and 2, and on page 26, just problem 9. Do those for tomorrow.